For step 2c, I'll start with the main function. I'll copy it in from the HTDAP template and edit from there. For this program, our analysis task is creating a scatter plot of the births and deaths in BC from 1975 to 2012. I'll rename the analysis function so that its name implies what it's doing. I'll call it plot births and deaths scatter plot. I also need to update main signature. As I mentioned before, all of our visualization functions will return none. They will show the visualization and then return none. So since main is returning the result from plot births and deaths scatter plot, it will also return none. Next, I'll update the purpose. Reads the file from the given file name, and I'm going to change it to say plots a scatter plot of births and deaths and returns none. Next, we need some examples for main. I'm going to copy those to an edit, as the main and read both take CSV files as input. In main, we expect the return value to be none. Note that the examples will not help us check if our scatter plot looks the way that we expect it to look. Instead, our examples will help us check that we're able to call the main function, that the value none is returned, and that there are no errors. If errors are generated, then we know we need to fix them. If I were to run this now, I would get a name error because I have not yet defined my plotting function. So let me write a stub for that, and then we will run our test for main to make sure that they run without errors. First, I'm going to add an import statement to the top of the cell. In order to use our plotting library, we need to import pyplot from matplotlib. Next, I'll write the stub for plot births and deaths scatter plot. I'm going to copy the name because that's a long one to type. Now I can work on the signature, and I see that this function takes read's output. Read outputs a list of population change, so this function must take in a list of population change. Because it's showing a graph, I know that its return value will be none. I'll say plot a scatter plot of births and deaths from LOPC and return none. And then to finish the stub, I'll include the return value. Now when I run this cell, I expect my test for main to run without error. And they do. Now we need to design our examples and tests for plot births and deaths scatter plot. This function takes in a list of population change. So I'll use these lists up here as example inputs. Our function should output none. So in both of my tests, I will expect the output to be none. Again, this doesn't help us check that the scatter plot that we create looks the way that we expect it to. but it does allow us to check that we can call our function with the expected input and that it runs without errors, or of course, if it runs with errors, it gives us an opportunity to fix them. There, now I have 2 tests. I'll run my tests, and they're passing. Again, the fact that they're passing doesn't mean anything. If I scroll back up, we can see that we are always returning none, but we are not creating a scatter plot yet. The test just happened to pass because we're returning none and the expected value is none. Now we're at the template phase. We don't have a template for a visualization function in the same way that we do for the other functions. So what I will do is copy and paste in from the worked example and edit from there. I'll comment out the body of my stub and paste in the body of the function from the worked example. So this is the visualization worked example for scatterplot. I can see that the template note is based on visualization. And the first line says areas equals convert counts to areas counts. Now, since I happen to know what this worked example is, I know what this is doing is trying to create sizes to create different areas for the markers of the scatter plots. We don't need to do that. If you want to know how to do that, you can go look, but we don't need to do that, so I'm going to delete it for now. We'll update the labels. So I've updated the X label, the label for the X-axis, the Y label, the label for the Y-axis, and the title of the chart. The next I see I could set the axis. I'm going to comment that out for now and we'll come back to that. Finally, I get to the line that creates the scatter plot. Looking at this line of code, I notice that it says plt.scatter. If I scroll up, I've imported pyplot as the full word pyplot. So everywhere that it says PLT, I actually need to update that. So now looking at this line, it says create the scatter plot with markers that are red and triangular. I'm going to remove that and also remove this S equals areas. That's related to the size of the marker that I said we were going to delete. So here, from the worked example, it's left me with calling scatter with ages and salaries. In the worked example, we were trying to plot the ages as one variable and people's salaries as another variable. So what these represent, and we could see if we went back to the worked example, are 2 lists of either integers or floats. So I'm going to delete those. What we want to plot is births and deaths. Now, births and deaths don't exist yet. So I need to actually be able to create those variables. I need to get a list of all of the births from LOPC, the input to this function, and a list of all of the deaths from LOPC, again, the input to this function. I'll also update this comment so that it's consistent. So births equals, let me think about what I need to do here. I have a list of population change, and I need to extract a list of only the births. So 1 integer number of births per entry in LOPC. That sounds like a different task. So I will create a helper function to get the births. I'll do the same thing for deaths. When you're working on your project, you will need to create helper functions to help you get the data that you need out of your list of compound. So my LOPC is my list of compound, and I need these helpers to help me extract whatever I need, or perhaps calculate whatever I need in order to pass it to my plotting function. For this example, we're just extracting births and deaths. But for your project, you need to do some more complex computation than that. Let me now write the stubs for these functions so that I can run my code, and then we'll finish designing those functions. I want my function to return a list of int because I know that births are represented in the compound with an integer. If I couldn't remember, I could scroll up and check my data definition. And for the stub, I'll just have it return an empty list. My getDeaths function is very similar, so I'll copy and paste and update. There we go. So now we have stubs for both getBirths and getDeaths. If I run my code, I hope that it will run. And it does. There's nothing in the graphs, but that's what I would expect at the moment. If I scroll back to the plot function, I can see that I'm plotting an empty list. Births, when it's just a stub, and deaths will be the empty list, so I don't expect to see any dots on my graph yet. Now I need to complete the designs of getBirths and getDeaths. Since these are functions that you know how to design, I'm just going to pause the video, finish the design, and then restart the video. I have now completed the designs of getBirths and getDeaths, including examples and tests below. Now if I run my program, now I can see my examples and tests are generating scatter plots with a few data points. If I scroll down to where I'm calling main with my full set of information, I can see that it's showing me the full scatter plot. If you remember, I commented out the line about the axis. So PyPlot will choose default axes depending on the data that it's given, and here it looks like it's done a pretty good job of that. I can see that most of my scatter plot is full of points, and I don't have a lot of extra white space. If I want to change the starting and ending points of the axes, I can do that. So let me show you how to do that now. So this line here, pyplot.axis, these were the values for a different example. So here perhaps I want to be able to change these. So let's try choosing these. Maybe X we want to go from 35 to 50,000. And we want the Y-axis to go from 10 to 35,000. Now let's run again. If I scroll down to my bottom, there I can see my graph now looks a little bit different because I've changed the axes. And it's going exactly from 10 to 35,000 on the y-axis and from 35,000 to 50,000 on the x-axis. If you set your axes values, think carefully about what most honestly and clearly communicates the data that you're visualizing. So now we've completed our scatter plot example inside of a How to Design Analysis program. As a reminder, as I scroll back up to the plot function, in this example, we simply extracted the births and the deaths from our list of population change. And for your project, you'll need to do more computation than that.